Hi guys, it's Marty the OT Guy here. Back today to talk about some things you can do with Nozomi Networks products that can help operational technology teams diagnose network problems. We'll start off with a funny story. We were dealing with a remote site here in New Zealand, right down in the South Island, wonderful South Island for anyone who's been there, Lord of the Rings and all those things. And we had a wind farm. The primary comms connection was via satellite. And over time, we found out the hard way. Of course, we didn't find out while this was happening, but over time, the satellite communications were dropping off, and it was progressively getting worse and worse, and we couldn't really understand what was going on. And it's a long way to get to this place. It's very remote. We're flying from one end of the country to the other. We then have I think it was nearly 2-hour drive, 4x4 off-roading to get to the site. And yeah, we couldn't work out what was going on with these comms issues. And what we really needed was a way to diagnose the problem. And of course, as you do, you work out how to do it when you've got the tools and after the fact. But so what would happen was the satellite communications would misbehave, and it would go in and out, or it'd be shaky for short periods of time and things like that. And progressively over time, it got worse and worse. So when we did the site analysis and we finally got to have a look, what we found out was some fencing was broken, and some local cows had managed to work out that a really good way to get a back massage was rubbing up against the transmission arm and LNB on a 1.2 meter satellite dish. So whenever the cow needed a back scratch, he would wander up, sidle up against the satellite dish and get jiggy and have a good rock around. And then as he went back to the herd and told some of the other guys, progressively they came along, and they were all rubbing up against the satellite dish. And in the first instances, we could only assume that while the cow was rubbing, of course he's rocking the whole satellite dish, which is knocking the alignment out. And then progressively, as they used the actual dish itself, it slowly rotated the disc and knocked it out, the dish rather, and knocked it out of alignment. So yeah, we worked this out one day when we were actually there on site, and the cow walked up and did it right in front of us. That was our diagnostic tool. But over time, it would have been so much easier if we could have worked it out on the fly. So yeah, today's session, let's share three ideas about how you can diagnose network problems using Nozomi Networks tools. Okay, so the first thing I want to talk about is monitoring network retransmission. So when you've got a Nozomi Networks appliance, a Guardian appliance in your network, and you are monitoring links and sessions and throughput and all the good things that comes with that, you have the ability to look for retransmissions. How do we pick up retransmissions? Because it's on the network. You're going to see it. If you took a packet capture, you're going to see retransmission data inside that packet capture. So we can set up alerts and things called assertions. An assertion is sort of like a question where you say, if A occurs in B time, then create an alert. Or you can just have an assertion that just if A occurs in B time, just assert, let us know. It doesn't have to alert. So that's really how you do it. You would set up a monitoring query that would monitor the network link that you're looking for, and when the retransmission rate exceeds a given set point, yeah, you can create an alert from that. So that's kind of cool and very useful for monitoring important critical links, primary links, or something like that. And it reminds me of another story. We did this with a customer recently, where during a trial session, during a proof of concept, the customer commented that the communications to this one particular remote site were always a problem. And we looked at it, and we were able to help them diagnose really quickly just by picking up that retransmission rate and showing how bad it actually was, were able to diagnose really quickly that the microwave link they had in place, so microwave dish at one end, microwave dish at the other, the microwave link they were using, the dishes were slightly out of alignment. So they sent a technician out to site who rotated the dish slightly, got it back in alignment, and all of a sudden all their retransmission went away. So yeah, the proof in the pudding there was it was really easy for them to be able to not go, we've got this problem, I don't know what to do with it. It was, we've got this problem, we've proven it, we can fix it. It was a really fast turnaround on that one. So that was cool. That was a good win. So let's look at the equipment we're using to demonstrate, to do this experiment in the lab. So I've got some cheap CCTV cameras connected to my lab network. They go through a variety of infrastructure and end up at a network video recorder. And along the way, my Nozomi Networks Guardian appliance is monitoring the traffic. Taking a look at the query, you can see here, screenshot from the Guardian appliance. I've entered the query, you can see the results. There's some fairly high retransmission rates in there. This is deliberate, it's the way my lab is set up, purposely for this experiment. Now let's dive deeper into how this query works. And we've presented it here in what I like to call Vantage format. And the difference between our Vantage SaaS platform and the Nozomi Networks Guardian appliance is the way that the queries are presented visually. So in the Guardian appliance, you see it all as one big long string. Whereas Vantage format, which is, that's my term, breaks it down into separate lines, which makes it a little easier to understand. So let's take a look at what's happening. On the first line here, we're referencing the links table. The vertical line at the end, the pipe, then sends that on to the next command. So second line, we're saying where TCP retransmission .% is greater than 10. That's all, it's self-explanatory. It's really, really simple. So we're pulling a data set from the links table of all records where retransmission percentage is greater than 10. We pipe that through to the third line and we do a select command because we want to display this data in a meaningful format. And I've deliberately used some features here just to make it a bit easier to read. You don't have to do it this way. So starting from the left, we select from, then you see the right arrow, which is a hyphen sign and a greater than. And we're taking lowercase from to from with a capital. The right-hand side of that expression becomes the new name for the column on the report. So reading through it, we select from, we select to, we select TCP retransmission %, and we rename those to from and to with a capital F and T, and retrans % as a more readable result. And you can see in the screenshot below, that's our report that's come out. Nice and simple. So let's look at this in a slightly different way. What if we don't want a table as an output? Let's look at a network graph query. Why can't we create a network graph? So this is using similar inputs to get a graph output. It could be easier to read. It might make life simpler for the users or for the engineers that need to work on this. So let's break down the query again here in Vantage format. This time it's a bit more complicated because to use the network graph feature, we have to be referencing the nodes table. So we have to do a join. The first line, we select the nodes table. We pipe that to a join command, which is the second line. The second line is joining the nodes table and the links table using the IP column from the nodes table and the to column from the links table as the common, call it a key if you like a database key. So the first two lines we're saying take the nodes table, take the links table, and I want a data set that my resulting data set needs to be all of the entries where IP and to have the same IP address in them. We then pipe that into a where command. So we're saying where joined link IP to. That is a new column that's created as part of the resulting data set. Joined link IP2 TCP retransmission percent greater than 5. This time I went for 5%. Obviously, you change that to suit the threshold that's relevant in your environment. Finally, we pipe that through to the graph command. In order to use this graph command, we set three parameters. So the first one we're setting is node label, which is IP address. The second one we're setting is the node perspective, and we're saying use roles. So I want to see each individual device. I want to know, is it a producer, is it a consumer, a server, the role it plays within the network. And the third parameter we're testing is link perspective, TCP retransmitted bytes. So that means that the arrows showing the links will change color depending on the level of retransmission present on each link. The second one we're going to move on to is about network transmission rates, throughput rates. So we had a customer reasonably recently, who needed to be able to monitor the average throughput over time for given transmission links, given communication links. So in their case, they had radio connections between sites, and they needed to know that the communication throughput stayed within certain limits over a 7-day period or something like that. They had to report on that as part of their performance metrics. So they asked us to design and implement a feature which allowed them to do that. So we're now able to look at network throughput for any given link and alert or assert based on a high or low level. So for instance, if you've got a radio link from point A to point B, and you know that it runs at a constant 50 megabits per second, or fairly constant 50 megabits per second, you can put some alerting figures, for argument's sake, let's say at 40 and at 60. So we have 40 and 60 as our lower and upper limits. We have 50 as our normal operation level. And if the network traffic peaks outside of 60 or drops below 40 for a specified period of time, we can raise an alert based on that. Why is that important? Well, you could have, if you're losing network throughput, if it's dropping off, it may be indicative of devices that are failing in the field. You might have something that's given up and it's starting to drop away, or the throughput drops away because the device has failed. It may not be a critical device, and perhaps you don't detect it, or some other part of the network that you can't necessarily pick up through a critical failure. If you have a spike in traffic, that could indicate that someone's added something new to your network. Some behavior is changing. The throughput, maybe it's retransmissions again. Maybe there's a whole lot of messages going backwards and forwards just for that, and it's taking up more and more network throughput. Okay, lab session 2. For this experiment, we're using a PLC, an HMI and SCADA workstation, and an engineering workstation within my lab environment. My Nozomi Networks Guardian is monitoring the traffic. So let's take a look at this query. This one's a little different from the last one we used because I want the output of the query to be an assertion. An assertion, think of an assertion as a true, false, yes, no, on, off, red, green, binary output. So in this case, we've got it showing up, it's giving us a green line, a green box there to say that this assertion is okay. And what we're doing here is we're looking at traffic looking at link traffic between two nodes, and saying, hey, if it's not transmitting enough traffic, or if it's transmitting too much traffic across a 15-minute period, then can you please let me know about that? Let's break the query down. So we start with the links table. Pipe that through to the first where command on line 2, where we're selecting the one end of the link, which is, in this case, it's .50.35, which is the SCADA workstation. pipe that to the third line, we're selecting the to end, the other end of the link, which is .50.60. That's my small PLC. Pipe that through to the fourth line. We're looking at transferred last 15-minute bytes. How much traffic went through over the last 15 minutes? And we're saying here, if it was less than a megabyte, then I want to know about it, and pipe that through to the fourth line. The fourth line being the same condition, however, we're saying if it's greater than 100 meg this time. So really what I'm doing is I'm saying, is my PLC transmitting any traffic at all? And because this is just for a lab example, I deliberately used really wide parameters there. You could narrow that down. You could say, I've got a link between this station and that station, and I know that the traffic should be 500 kilobits plus or minus 50 kilobits. And you could change the parameters in here and really narrow that up. And what we're saying here, that final part on line 1, 2, 3, 4, 5, right at the very end, we pipe that through and say assert empty. So we're saying if the traffic is inside the parameters we want, I want a green box. Have you ever had those times in your career when you submit some compliance reporting or some trends for analysis, and someone comes back to you and says, can you please explain this gap in the trend for, let's say, 2 days? There's a gap in the trend, and you went, I'm sorry, what gap in the trend? Or you maybe didn't know that that data was missing. You found out the hard way. How do we solve that? What can we do about that? Well, we are able, the Nozomi Networks product is able to monitor when a device last communicated. So it's sort of like throughput, but instead of looking at volume, we're now looking at time. So we can set up alerts and assertions so that if a device doesn't communicate for a given period of time, we trigger an alert. Let's say you have a 12-hour compliance reporting requirement. You need to maintain your reporting and trending, and you're not allowed to have any outages greater than 12 hours. It'd be a really good idea to detect a loss of communication, a link drop, or last time that a device was communicating, maybe at 8 hours. Maybe you pick it up at 4 hours, and that gives you plenty of time to do diagnostics and hopefully fix the problem before it becomes a compliance issue. Okay, lab session 3. Same as before, we're using the PLC, the SCADA HMI workstation, and the engineering workstation with the Nozomi Networks Guardian monitoring the traffic. So this query again, we're using an assertion, but this one is misbehaving this time. You can see it's got a red line, so it's a bit different. Let's break it down. Again, starting with the links table. Well, this time I'm excluding some traffic. I don't want traffic. The 0.0.0.0 address in my Nozomi Networks Guardian configuration is used as a catch-all for all of my public IP addresses or anything that's not within my lab. So it's saying I'm not interested in links that are trying to reach the internet or trying to get to my home network or in any way related to my management or anything like that. Let's look at that third line, where to exclude 224.0. Okay, so I want to exclude 224.0 addresses, which, they're a management address. I don't want to know about it. Next line down, where to exclude FF. I don't want IPv6 in this response, in the result rather from this query. And then next line down, so we're now on 1, 2, 3, 4, 5, where to is not equal to my public catch-all again. So I don't want traffic going to or from there. Now we get into the interesting stuff. So the next line down, we're saying where the last activity happened greater than 2 hours ago. So if I know that I have a PLC that should communicate roughly every hour, then I can set that to be greater than 2 hours. We haven't had a response. Something might be wrong. We come down again and we say where the transferred average packet has dropped below
below 1,000. So now we're saying it's been greater than 2 hours and our average traffic is much, much lower than we expect. We maybe have some problems here. So I put in a select line in there. This is sort of a demonstration of how not to make a query in a way. We've got select in there. We're saying, hey, give me from to transferred average packet bytes. But then we're piping through to an assertion, which means we're not seeing the output of the select command. So yeah, that's a deliberate mistake. That's showing you how to, well, you can believe it's deliberate or not, I don't mind. But it's a deliberate mistake to show you what would happen or how it may not result the way you expect. The query still works properly. But what we don't get is the table, the data table coming out from the select command. Okay, so this next lab session, we're using the same configuration as before, but what we're doing different is we're going to use the link state rather than the links table itself. So it's a slightly different query, and let's take a look at it. The first thing we do is we start off with the link events table. We pipe that through to our first where command. So we're saying where the event includes down. So now we're looking at links that have gone down. It's not there anymore. Pipe through the next one, where hours ago time, less than 24. So we're saying what has happened in the last 24 hours, have any of these links gone down? Pipe through again, and we've got a big long select. So we're sort of combining everything that we've covered in these labs here. So we're selecting ID source, but we're renaming that to from. We're selecting port source, renaming that to from port. We're selecting ID destination and calling that to. We're selecting port destination and calling that to port. And we're selecting time and calling it time, and same with protocol. Selecting protocol, calling it protocol with a capital P, and you can see there the resulting data set and table that we got out of that.
So that's my three tips for this session. If you're coming into OT from the IT world, some of this might seem a little unusual or a little different. If you're working on a campus, you're working in a large campus, how often a device communicates, or even in some cases, how much bandwidth it's using, isn't often that important. It might not matter if a given endpoint goes from 50 megabits a second to greater than 60. Who cares? It could be a use case thing. But in the OT world, that could be indicative of some problems in your network or things that could go on to affect production or compliance. So it's pretty important that we keep an eye on those kind of things. So that brings us to the end. I look forward to catching up with you next time. And I'm really interested, could we get some feedback from you people out there? Would you find it interesting to learn about some core OT concepts, such design or digital and analog inputs and outputs versus communication devices versus, a bit more technical detail on how OT systems actually work, rather than just how we're using it within the Nozomi world? The two things fit together really well. We could have a lot of fun discussing some of those things. If you're interested in knowing more about that, let us know. We'll see you next time.